In this video, we have another example of the arc length formula, but in this case, we are looking at integrating with respect to y. So we're going to let g be a function defined as g of y, where we have g of y is equal to x, and y is defined over a closed interval from c to d. The arc length formula we're going to derive in a different video, but here we're just looking at examples on how we can integrate when we're finding the length of the curve. So for this example, we want to find the exact length of the curve, x equal to what you see there, for y values between 1 and 2 inclusive. So the first thing I want you to know is, or to notice, is that we have the graph here, and we're only looking at the graph for y values between 1 and 2. So if we're looking at y values between 1 and 2, then we're only looking at this function here. So the entire graph is not a function because it does not pass the vertical line test, but the portion of the curve that I've highlighted does pass that vertical line test. So what we want to do is we want to find the exact length of the curve. And again, we're going to find this length using the formula provided. And that is using or getting the integral from c to d of the square root of 1 plus g prime of y squared dy. We know what c and d are. We know that c is 1 and d is 2, so we're looking at the integral from 1 to 2 of the square root of whatever we get here, which we're going to be doing on the side, dy. Let's talk about g prime of y. So we know that g of y is equal to x. So let me rewrite x here. This is side work. We're gonna say x is equal to y to the 4th over 8 plus y to the negative 2 over 4. So x is equal to g of y. And now we're gonna take the derivative of g with respect to y. So we can say that g prime of y is equal to 4y cubed over 8. And then we can say minus 2y to the negative 3 over 4. Which we know we can simplify. G prime of y is equal to y cubed over 2 minus, I'm going to write it down as 1 over 2y to the 3rd power. In the next step, according to our formula, we just found g prime of y. Our next step is going to be to square. So if we square g prime, we have g prime of y to the 2nd power is equal to y cubed over 2 minus 1 over 2y cubed, and then we know we have to square. So when you squared, you are going to have y to the 6th over 4 minus 2 times y cubed over 2 times 1 over 2y cubed, and then we have plus 1 over 4y to the 6th. We know we can simplify a couple of things. And after you simplify a couple of things, you get y to the 6th over 4 minus 1/2 plus 1 over 4y to the 6th. So again, this here is g prime of y to the 2nd power. Now what we're going to do is we're going to get our g prime squared and add 1 to it, because again, the formula requires us to add 1. So if you add 1, I'm going to write it down. We have 1 plus g prime of y squared is equal to 1 plus y to the 6th over 4 minus 1/2 plus 1 over 4y to the 6th. So when you add 1, you now get y to the 6th over 4 plus 1/2 plus 1 over 4y to the 6th. And then I like to make an observation here. When we squared, this is what we got. So now what I want to do is I want to go backwards. What we need to do is we need to factor out this trinomial. So when you factor it out, the only difference is the minus. So it's going to factor out into y cubed over 2 plus 1 over 2y cubed, and then it's going to be squared. You can do the work too, or you can check it if you want, but you can just think about the trick. The first and last terms are the same, but the only thing that you see different is that positive 1/2 or that negative 1/2 the first time around. Remember, this here goes inside the radical. So we can say that the length of the curve is equal to the integral from 1 to 2 of the square root of y cubed over 2 plus 1 over 2y cubed squared dy, which is equal to the integral from 1 to 2. We can simplify the square and the square root, and then we can say y cubed over 2 plus y to the negative 3 over 2 dy. However you decide to go about this, it's okay. I'm going to show as many steps as possible for those of us that need to review. All right, so we have 1/2, and now we integrate y to the 4th over 4 plus y to the negative 2 over negative 2, and we're going to evaluate this from 1 to 2. So let's see where this takes us. We have 1/2, and now we're going to evaluate at 2. We're going to evaluate at 2, so we have 16 over 4. Y to the negative 2 over negative 2 is really equal to negative 1 over 2y squared. So when you evaluate at 2, this right here becomes a minus 1 over 8. And minus 1/4 minus 1/2. So you're evaluating at 1/4 minus 1/2. Now, if we just finish this up, we have 1/2, 4 minus 1/8 minus 1/4 plus 1/2. And again, however you decide to go about this, I'm okay. LCD is 8, so we'll have 32 minus 1 minus 2 plus 4 over 8. We have 32 minus 2, that is 30. 30 plus 4 is 34, minus 1 is 33 over 16. So the exact length of the curve from 1 to 2 is equal to 33 over 16. I'll put L equals because that's the symbol that we use for the length of the curve.